Hey everybody, and welcome to our video on probability of two events. If you are not familiar with probability, you should definitely go back and watch the video on simple probability first, and then come back to this one, because what we're talking about here is when you are calculating two or more events together in probability, and they can either be independent or they can be dependent. And we're going to be focusing on that vocabulary and focusing on solving. All right, so if you need a refresher of just basic simple probability, go watch that first. All right, if I have two events that are happening, they can either depend on each other or they can be completely independent of each other. All right, if they are independent, that means the outcome of one event does not influence the second. Versus if they are dependent, the outcome of one event does have an impact on the second event. All right, and just a little fun English trivia. The prefix in actually means not. Like indescribable is not describable. Independent means they do not depend on each other. I'm sure you can think of other examples. Leave them in the comments below. We are not English teachers, so that's the best you're going to get from us. All right, for independent events, there are some words, some signal words that will help you decide that what you're looking at is independent. Okay, if the problem involves a coin or a spinner of any type, it is automatically independent, with one small exception of spinners that we're not going to get into. But on a typical spinner or a typical coin, after you use it, the piece that you got doesn't disappear, right? If you flip heads on a coin, heads doesn't disappear. Or if you've ever seen Wheel of Fortune, once they spin the $500 is still there. Okay. Also a number cube, which is what the state of Virginia likes to call a die or dice. If you roll a 3 on a die, the 3 doesn't go away. But there are also some other words. If you see the word replace, so if you draw an item and then you replace it, or you put it back, or you return it, those all mean you're dealing with independent events. Whatever you drew out the first time is still going to be there. However, in dependent events, something changes. In fact, I'm going to add that underneath the definition. I'm going to put something changes or disappears. Disappears? Does disappears have one or two S's? I'll let y'all tell me that one in the comments too. And you will see that happen when it says, like, you draw a marble and then that marble is not replaced, or that marble is not returned. Or sometimes the item will be food, like a piece of candy, and it will say that the first piece was eaten. So in that case, something has disappeared, which makes it dependent. All right? So let's see if we can just figure out this vocabulary for a minute. We're not solving anything yet. We're just trying to decide if something is independent or dependent. This first one says Mr. Akers chose a piece of chocolate from a bag, eats it, and then pulls another piece of chocolate. And I remember that we wrote that in our signal words. So these two events are dependent because the bag of chocolates was affected, right? Something changed, something disappeared. I'm going to write because Mr. Akers ate the piece of chocolate. And then in parentheses, I'm going to write disappeared, which I might be spelling wrong this entire time, but there you go. And then the second example says Jasper pulls a card from a deck of cards, puts it back, and then pulls another card. And putting something back or returning it was another one of those signal words. And this time it tells me that these events are independent because the first card was put back. Nothing disappeared, nothing changed. It was put back in the deck, and the next time you draw a card, there's just as many as there were the first time. So, the big question is, how does this affect the actual math of probability? Well, I've got two examples here, and they are very, very similar. One is independent, one is dependent, but the stories are almost the same. So I'm going to read the one on the left and underline signal words, and then we'll see how the one on the right is different. So the one on the left says Amy has a toy gumball machine. The toy comes with 10 gumballs. 2 are blue, 5 are yellow, and 3 are pink. What is the probability that Amy will choose a pink gumball, eat it, and then choose a blue gumball? So I underlined my signal words. And because Amy is eating it, I know that this is dependent. Now, before we solve, let's compare this to the one on the right. Amy still has the same gumball machine. It has the same number of gumballs, but the question says, what is the probability that Amy will choose a pink gumball, put it back, and then choose a blue gumball? Maybe she doesn't like the pink flavor. I don't know. Okay, so I underlined my signal words, and this one is independent because this time she put it back. So instead of the number of gumballs changing, they stayed the same. So let's do some probability. The first time that Amy gets a gumball, the chance of her getting pink is 3 out of 10. But then she eats that gumball. So instead of there being 10 gumballs, now there are only 9, and 2 of them are blue. So if you're thinking, whoa, 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 you got way, way, way ahead of me, let's make ourselves a little picture. So we know that in her gumball machine, there were 2 blue gumballs. So I'm going to try to make 2 blue dots, 2 blue gumballs. There were 5 yellow gumballs. 1, 2, 3, 4, 5. And that there are 3 pink gumballs. 1, 2, oh goodness gracious, 2, 3. There we go. So when she first reaches in to get a pink gumball, there are 3 out of 10 that are pink. But then she eats that gumball. It's gone now. So now the chance of getting blue is 2, because there are 2 blues, out of 9, because there are only 9 gumballs left. All right. Then we multiply straight across and we get 6 over 90. And that can be simplified to 1 over 15. And I will show you how we simplify in just a minute. Let me go ahead and do scenario 2 before I end up splitting the screen with Desmos here. So in scenario 2, it starts off the same. Amy wants to choose a pink gumball, and there's a 3 out of 10 chance that's going to happen. Then she puts it back. So she picked this pink gumball, but then she put it back. So it's still there. So when she goes back to get a blue one, the chance of that happening is 2 out of 10 because all 10 gumballs are still there, which gives me 6 over 100. And then I will show you how we simplify this. Let me grab Desmos. So you've probably learned how to simplify at some point. And if you are in a higher math where you are using a different version of Desmos, it will do it for you. but we find that a lot of our students struggle to simplify unless we give them a method, which is totally fair because it's a tough concept. So the way that we show our kids to do it in the calculator is we put the numerator over x, we put the denominator over x, and then we start guessing x values, but you start with the numerator. So in this case, the numerator is 6, and what you're trying to avoid is decimals. So if you get a decimal, that means that did not work. That is not simplified. Erase the 6 and go down from there. So 5 still gives me a decimal. 4 still gives me a decimal. 3 still gives me a decimal. 2 gives me 2 whole numbers. So my simplified answer is 3 over 50. And you could do the same with the 6 over 90 as well. Now there is one more little part to this question underneath where it says convert each probability to a percent, and then which has the greater chance of happening. So scenario B was 1 over 15. If we make that a percent, it's 6.7%. And then scenario B was 3 over 50. And if we make that a percent, it's 6%. So which has a greater chance of occurring? That's going to be scenario number 1. So if you had 2 people actually act this out in real life, there is a better chance that you would get pink and then blue if you ate the pink one first. All right, that's probability of 2 events. Get out there and do some practice, and I will see you next time.